majority of the prints are done at 45 degrees because that kind of minimises the supports you need. There's very minimal peel out of there, for example, and it also tends to avoid distortion by this I guess uneven cooling rates, or I'm not entirely sure what causes it, to be fair, but some materials contract more than others, possibly moisture content as well, but it's not an easy thing to eliminate. But printing at 45 degrees like that, a bed like this, reduces the amount of supports you need. So a little bit of cleaning up on this one to do, but not a huge amount. And if you've got good settings on your machine, getting supports off can be very easy. If the settings are wrong, it can be a real pain. So we're going to clean these up, press them together, see if they fit. And then we've got to do the wiring on the motors, and then we start putting it all together. So that is the back of the shoulder. This is the pitch rotation, and the yaw rotation goes through there. The motor sits through there. And there's a metal clamp here, and that has the pins which restrict the range of movement. And then there's two pretty hefty M6s, and they take the torque off the motor and transfer it back to here where the main pitch bearing is. So that one came off really easy. This is the front. In fact, I already started, but that also comes off very easily. And then this lot might be more interesting, because this is like this, and I printed it that way because I wanted to get a good surface finish here. But if it doesn't peel off easy, then that would have been a mistake. Yeah, not bad. Okay. So, pliers, screwdrivers, cutters, whatever works. And I often wear gloves on both hands, in fact, because you can still sometimes slip with the one holding the tool. But it's a very good idea to wear a glove on this hand, particularly if you start using blades and other sharp implements, because it's very easy to slip. Where are my pliers? screw hole. Goes all the way through there. Which apparently I've lost a bit of there, but that's not a big deal. And what's kind of remarkable about the CF nylon to me is that the inter-bond strength between the layers is exceptional. I mean, it really is so strong in cross-section. Most materials will shear very easily, particularly PLA is a nightmare for that. It's so weak, the inter-bond. But nylon is, if you print a bar vertically or horizontally, there's not that much difference between the breaking strain. At least 60–70% when all the fibres are aligned compared to not, which I find astonishing. I mean, especially as it actually peels incredibly easily if you get the settings, I guess, just right, which is a kind of contradictory property. It has a strong bond strength, it should be hard to peel, but I find it one of the easiest materials to peel. So all in all, apart from the fact that it's 3 times the price of anything else, it is a fantastic material. It's remarkably strong, great dimensional stability. But it's very hard wearing, so you do have to use a hardened steel tip at least. I guess some people might be using ruby. I've never tried it myself, but I hear it sticks. Well, thank you for the thumbs up. Not sure this is really worth watching, but you know, you get the idea. And this is our yet to be tested clearance for the kind of combined deltoid bicep tendon. And that will run across the top of the pitch joint, around the edge of the yaw, pass almost exactly through the centre of the humeral rotational joint, and then add to the elbow. And that, I believe, will give the arm remarkable lifting strength directly in front of it. So these can be quite tricky to clear out. Let's give it a wire or something else. Flexi drill, 2mm drill. Not a great design, frankly. I'll look at that if this works well. Make it easier to assemble. But that one's peeled apart from that hole now. Not too bad. Bit of flame just to tidy it up in places. Not sure what happened there. So these two fit into a bearing, and then the inserts press up and lock the whole thing together. The bearing pass around here. That gives a very nice strong structure. And these are the keys, in fact. little bit tidying up, a little bit of filing, and that should go together. Broke that one. No. Broke most of them, in fact. I don't think it matters. Certainly not too much. It'd be nicer if it didn't break off, but what can you do? A bit too ambitious, ripping that whole lot off in one go. These can be melted back or just trimmed off. Same with that one. Hole through that, that came out nicely. And then trim off all these scraggly bits, and then probably finish with a file. But as long as it, in fact, fits, it doesn't matter if it's a firm lock. If anything, that's probably better. Yeah, not bad. Bit more finishing up, bit of pressure, that'll fit in nicely and lock it all. And then the additional screw holes are really to retain the aluminium collar, which will then retain the motor. Be a little more careful on this one. See, it's already lost that one anyway. Check the layout. Seems to be there. It needs to be a little bit higher off the deck. Force a bit more spore material underneath. Make those arches a bit stronger. One's intact. Shouldn't really make a difference. That'd be enough. These are a bit broken too in places. I think that's probably, oh, that one's pretty good. Ah, yeah, see, the one printed at 45. These have also come out much better. It's one of the issues printing with a 0.6 nozzle. But these lot were printed, yeah, like that, so the layers are not as strong in that plane. But this one's done that way to maximise the strength of this ring. Although frankly, I think that's a bit short-sighted. This will probably need to be made removable in the future. Just going to get a file like this. Use it to knock off as much as possible any high spots. If you've just joined us, this is the cleaning up of 3D prints to make a robot arm. Feel free to post questions in the comments or chat. Okay, so that goes there. Not bad. Squishing. So in the end, you don't force them together with a pair of plumber's pliers or plumber's wrench, I guess you could call it, normally adjustable head size. That's already pretty much there. I'm worth running a bit of flame over it just before I put it together, soften up any little bits sticking up. It's best if it all goes together without having to be taken pieces and rechecked, so a bit of extra time now, make sure it all fits. Is worth it. Just that to sort out now. And that must be a printing fault. Something got snagged up, pulled across. This won't be visible, so it just needs to be cleaned up to be smooth. Now. This is the other side, and this one was printed differently. This one was printed at 45 degrees because the strength here doesn't really come from the plastic, it comes from these two bolts which go down and tap into the plastic, into this aluminium retainer. So this has almost none. That's pretty good. Side by side, you can really see the difference the printing everyone makes to the surface finish. Getting some problems on that, I'm not quite sure why, but in other areas much nicer. But strength, most important for that piece. these are going to fit onto a bearing. This is a thin section bearing. Let me get a way to measure it. 70 ID, 90 OD. They're not particularly expensive for what they do. For the quality and the strength and precision, frankly, they're amazingly good value. So what can take a bit of time here, of course, is when you press it all together, there's nothing really guaranteeing that this and this are square. As you can see, this one's tilted over this way. So that won't be fully trued up simply by pushing in the inserts. And once it is assembled, of course, it's quite difficult to change that. But as long as you can get somewhere near, the screws which hold everything together pass one near the top and one near the bottom, so you can get a little bit of tuning from that. I seem to remember there was a bit of a trick for getting in the spare bits, and I can't remember what it was. To get the keys in, you've got to do it in a specific order. A long time, almost a year since I made one of these. Okay. And a pair of pliers. This. It'll all start to press together. And you can see what's happened is it's made that open up. That's rotated round, and this is closed up. It can be covered to some extent like that. That's not too bad. A little bit off still. Oh, okay. This one's easier than I remember then. Must be another one. One of them is really awkward. Must be the next joint down, which is going to be smaller in size, of course. Okay, nice. That just slid straight in. So in fact, that's going to be the front of the shoulder joint. That's the pitch. Not bad. And there's bolt through here, bolt through there, and a heated insert there and there. This is for the electronic wires to come out in. That's power going in. This is the motor cables from this motor travelling down through there. And they pass through here and eventually will travel down into the upper arm. Okay. Shoulder pitch assembled. Actually, we'll need a bit of tweaking. See, that's not fully pressed in, but it shouldn't take much to finish off. Yes, I think from there it's pulled together with the screws. I think that'll all come good. This one's a little bit off as well, you see. There we go, it's better. Lovely. That's unfortunate. That holds a bearing, so that can probably be heated and then redone. Again, printed at 45. There's quite a lot of metal in the middle of this one as well, so strength-wise should be okay. That's what we're going to find out with this one. If you've seen any of the other videos for red and white arm, only ever ran up to, I think even something like third of maximum motor speed, and possibly half maximum torque, because it's made of PETG and I didn't want it to break. And then after I did the endurance testing, it actually needs a bit of repairs, which I will do once this one is working, because it will involve taking it to pieces, and it's the only working example I have at the moment. Don't know, not sure that's the right way to do it, but it's marginally less work as well. Now that's interesting. So this in fact is going to take a press fit of a bearing which runs outside of the motor around the gearbox casing, because the gearboxes themselves are ground and hardened steel, so that makes a very useful bearing surface. So you can just put a needle roller with no inner race straight into that. But I've added on this time, I've added these deep cutouts, because this is where the pins will go, with extra pins added in here, and here, and here, to form the stops of the shoulder. Looking at that, I wonder if that's weakened it too much. It doesn't seem great actually. I think I might break across that. I think this might be reprinted flat for the strength of it. In fact, they can be done this way. Because we're just interested in the strength that way, really. Not sure about that. The ones that did come out very well are the upper arms. So these just printed sublimely, frankly. And again, these are printed at a 45 with some extra supports included here and here, so that it doesn't get too wobbly by the time it gets up to the top, because it's really quite a lot of unsupported height otherwise. That's acceptable. So just a tiny bit of clear up. Quite a lot of loose stuff here. To check what it was doing there. Not using any kind of inline drying device, which is probably a mistake for nylon. That's not great either. Again, it's not structural, so I don't really care. I think that can just be a bit of heat. Press back in, that'll go. And then this is the other, how it takes the outside of a bearing. Another metal collar here, motor body here, sets of electronics, and now on this one, a door. But really, very nice fit. This one's not quite as good. Back came up pretty much the same. A little bit messing around in here. Heat, press it back round. Again here, probably the best thing to do because they're all being pulled up. There's material missing here. So something's gone wrong with the way it's pulling away from this edge. We'll probably melt those and press them into the holes. Hello. So, just heating up a hot air gun to do some slight repairs. Back of the spring came out perfectly. Underside where it was joined on is tolerable, but that's a bit messy. What I'll try and do is just gently melt them in, press them flat. Well, obviously it's not bad, but I can't do it easily on camera. But I'm just putting the blade like this, so I don't melt that edge. I'm blowing a bit of hot air and then swiping upwards. It gives a nice little finish like that. And then if you really want to go to town, go crazy on it, you can use body filling, lacquers and all sorts of stuff, like the guys that make the C3PO suits to get a fully metal looking finish. Seems like a lot of work, might do it one day, not on this one. But that's already a good start, can live with that, it's great. Yeah. That looks pretty well. Well, clearly we still need a lot of cleaning up to get it looking as smooth as that. So, still some experimenting to do with print settings. But that's the upper arm. Depending what I decide to do with these, I have a feeling I am going to reprint them. Those fit inside there with another bearing, same way as that one. So that's the front of it. It goes in there, and you've got the upper arm beneath it, and that forms a shoulder joint. And then at the end of that, of course, is an elbow joint. So this one has been printed flat to the bed to maximise the strength on this loop here. And this one has been printed at 45 to make it easy to peel. And it was done with the interlocking teeth upwards to minimise peeling again. See if it's made a difference and what the finish is like on this part. Not terrible, not great. This is what it can do. And that's what that's like. What can you do, eh? Balance of strength, printing ease, removal of supports, and looks. Dead easy, that one. Then we just work around the edges, loosening things up whilst trying not to damage what's underneath. Voila. Oh, yeah, just used to go. Oh, well, that's a shame. So, choices are to ignore that, glue it back on, which is what I'll probably do. Assuming I've got some super glue, because this is nylon, so it should glue pretty well. Or try and heat it up and bond it back with heat, which is a bit more awkward. Doesn't really matter in the great scheme of things very much, I suspect. I might change some of the screw depths. Can't remember if this one goes together. So same as for the shoulder pitch. Oh, clear enough to do that. These pressed together. The bearing size for these ones. It's 50. Actually, these might be wrong. I think it's 56. That's it. Oh, no, seems to be okay. 55s, yeah, they're 55s. Internal, 72 external. External. So, same thing. Let's clip into there. Oh no, wrong one. Again, got to make sure everything's square, but that can't really be determined until you do the final assembly. And same as the shoulder, there are two keys. One presses in to the top, one presses into the bottom. Right, I think we're going to set off these with a flat bed print for much greater strength, especially with the holes through there. That's just going to break across there, that's not strong enough. It might not be, I might have to get rid of those. Don't like that at all. Alright, let's have another look at that. I think those holes are too big. Drop into 4s, which makes holding too weak. Bye bye for now.